population model of bluebirds is measured using this function. When does the population reduce to below 1,500 if t is the time and p is the population? So whenever you have a function, you need to go into the y equals, press clear, and then type in the function. It's 1,350 plus 400, brackets 1.25 to the power of minus t. So this is going to be a small minus, and then we're going to have an unknown variable. We'll call this x because you can only write x, close brackets. And actually there is a bit of a punctuation or mathematical error here. The bracket should be here, so it matches with the actual question. So this is our question. Now if we press graph, we can see we cannot see the correct thing of the window. Now to do with population, we have time 0, and then time keeps going on, and then we need to start with a positive population, so we can see completely the wrong thing here. So let's have a look. Let's change our window so that our minimum is 0, the population can't go below 0. Our maximum, let's say 400, this is to do with time, not population. 0 is the time, 400 is the time. Let's go for minimum and maximum of the population then. We are going to have, let's say 0 is the minimum and about 2,000 is the maximum. Remember, when we're looking at this function, normally the letter isolated on its own will represent the y, so that's the population, and then the letter which is within an equation or within an expression, that's going to represent the x-axis. So t for time represents the x-axis. Let's press graph. Excellent. So we can see an exponential model. We've got too much of the x-axis here, so y-axis showing. So what we need to do is we need to go into the window again, and we need to change the y-axis so that the minimum is not 0. Let's change it to 350, and I'll explain later why I changed it to 350. That's much better. So, when does the population reduce to below 1,500? Now, there are a few ways of doing this, but the best way to do this question is an intersection question. If the population is 1,500, p is equal to 1,500, and we've said that p is representative of y. So you go to the y equals, on this y equals you type in 1,500, then we're going to press graph, and what we want to see is where they intersect. We still have too much on the y-axis, so let's change the window again. I'm going to change this to, let's say 1,000, graph. And this is where we want to find. At what time does this population reduce to below 1,500? So below this red line, the population is getting smaller and smaller and smaller, and it happens at this particular time. So we need to find out what this x means. I'm going to change the x values as well because we've got too much x values. So let's make them between 0 and 100, for example. Much better, much clearer. Now, to find the intersection, you press second trace, number 5 for intersection. You need to select one of the curves. This happens to be our model, our exponential curve. Enter. We then press the other curve, enter, and then somewhere where they both cross, enter. So at time 4.3955079, the population starts to reduce below 1,500. So when we're talking about time, because this is a continuous variable, do not round it. But in the exam, what I recommend you do is round it to 3 significant figures, but don't round it any further. Don't round it to 4 or don't round it to 5. You would be given the wrong answer. Now let's go on with the second question. This is to do with 2 lines bisecting each other, and this is a very similar concept. All you have to do is go onto the y equals, type both the lines in, 4x plus 3, and then on the second line we're going to do exactly the same, but this time with the second function, minus 3x plus 6. And we are going to click graph. This time the graphs are happening here and probably below the axes, so we need to see more of the window. We want to see negative and positive, so let's see negative 100 and positive 100, and let's make the y min and y max different as well. Let's change them to minus 100 and positive 100. I'm changing this to these values because I want to be able to see all 4 quadrants of the graph. There we go. We want to see where they intersect here. So we're going to press second calc again. We're going to find the intersection. We're going to select one curve. And then we're going to select the other curve, and then we're going to find the middle intersection. There we go. They intersect at 0.4, 4.8. And before I move on, I just want to quickly go over this question and explain why I changed the window differently to this question. When we have an exponential graph, so this is to the power of a letter or a power of a negative letter, we have something called an asymptote. This is the asymptote, 1350, and it's always the number on its own. So you might have a function, a letter here, which has been multiplied by a couple of numbers, and then we add to a particular number. This asymptote is where the function no longer in the graph. So the population starts at a particular number, and then it reduces to this asymptote. So it tends towards 1350, which means at one particular point in the model, the population will tend towards 1350, but never actually hit it. And this is our asymptote line, where the exponential graph becomes flat. And it appears like it's becoming flat, but it's just going closer and closer and closer to that 1350. So that's why when we change the window, we do not need to see much below the 1350 because nothing is going to happen here with an exponential graph.